Hey guys, section 1 of chapter 6 here. We're going to solve systems by graphing in our essential question, how do you solve systems of equations by graphing? A little warm up here, discussion, how do you graph a line that's in y equals mx plus b form? Basically, first we look at the b because that's where it crosses the y-axis, and we put the point at that spot on the y-axis. And then we use our slope to find our next point. So we go from that point that we just plotted, and we use our slope to determine the next points, and then we can draw our line. So some vocab here, and I'll be honest guys, some of this isn't real useful, but we need to go over it anyway. So a system of linear equations, that's what we're working with in chapter 6. It's just two or more linear equations. So linear equations are just y equals mx plus b. Okay, so it's just two or more lines, really. So you graph them. So for example, these two lines here, they're going to intersect. In this case, they intersect right here. And that's our solution. So in this case, there's only one solution because they intersect at one point. So it's any ordered pair that would be like a coordinate point, like, for example, 2, 3, right? That's an ordered pair. And it makes both equations true. So it's on this line and it's on this line. Okay. Now, these are the vocab words that honestly don't mean a whole lot, in my opinion, but we need to go over them anyway. So consistent is a system that has at least one solution. So basically the lines cross. If the lines cross, it's consistent. So this one would be consistent. Independent, the lines kind of do their own thing. They don't really copy each other's slope. They do their own things. In this case, these would be independent. They just kind of do their own things. Now, inconsistent would be a system that has no solution. So, for example, the lines never cross. If the lines never cross, they're parallel, right? And so these lines are parallel, so they're inconsistent. There's no solution. They never cross. There's no intersection point. And so basically, in practicality, what this means for us is that there's no solution. And that's why I don't like the inconsistent, consistent, dependent stuff. I don't think it's real useful. Basically, is there one solution? Are there no solutions, like in this case, where they never intersect? Or we can have one last case where technically it's called dependent, where the lines copy each other. And it's just like one line on top of the other. Okay, well here they're intersecting at every single point. There's an infinite amount of points that they intersect at, and so this would be infinitely many solutions. Oh, I guess it's written down here, sorry. Infinitely many solutions. These are in my opinion, the way more useful words. One solution, no solution, infinitely many solutions. All right, so let's get to it. All right, we're going to find the solution using graphing today. So we're going to basically just graph these lines and then we'll find where they intersect. All right, so this first one, let's just work on the top one. Our y-intercept is at -1. Let me use a different color. Use blue. Our y-intercept is at -1, and then our slope is 2. So we go up 2 to the right 1. Up 2 and to the right 1. Now, 2 points, you only need 2 points to make a line, but today I'm going to encourage you to do several for each line. It's just easier to see. And then we'll go down 2 and to the left 1, down 2 and to the left 1, down 2 and to the left 1. So I encourage you to do quite a few. And then we'll make our line here as best we can. There we go. All right. And then we'll do the red one. We'll do this one in red. So we're going to go down 7. 1, 2, 3, 4, 5, 6, 7 right here. And our slope is 4. So we're going to go up 4 over 1. Up 4. 1, 2, 3, 4 over 1. Up 4. 1, 2, 3, 4 over 1. Okay, and you see how the lines are kind of getting closer together. up 4, 1, 2, 3, 4 over 1. Ah, right here is where we're looking for. And then one more for good measure, 1, 2, 3, 4 over 1. Okay, and we'll make our line through here. Good enough. Okay, now you saw where we put the red dot on top of the blue dot right here. This is our solution. That's what we were looking for, is that point where they intersect. And so your final answer is always in a coordinate point. Okay, I'm going to make a big deal out of that. It's always a coordinate point. And our coordinate point is 1, 2, we go over 3, and we go up 1, 2, 3, 4, 5. We go up 5. So this is our solution. Basically what this means is that we can plug in 3 for x, and we'll get out 5 in this equation. And then we can plug in 3 for x in this equation, and we're also going to get out 5. So it works for both cases. And actually, I'm going to just prove that to you. We're going to, in the first equation here, 2 times 3 minus 1. So we plugged in 3. 2 times 3 is 6 minus 1. We get out 5. Okay, now down in this equation here, 4 times 3 is 12 minus 7 is also 5. So that's what this coordinate point is telling us. If we plug in 3, we're going to get out 5 for both equations. All right, a word problem here for us. Suppose one puppy weighs 5 pounds at birth and it grows at a rate of 0.25 pounds per month. And then another puppy weighs 4 pounds at birth and it grows at a rate of 0.5 pounds per month. And then we need to figure out after how many months will the puppies weigh the same amount. Okay, so puppy 1, they weigh 5 pounds at birth. Okay, so we're already starting off at 5. And then they grow at a rate of 0.25 per month. Okay, now if we want this in y equals mx plus b, it technically already is, but we can just switch stuff around here. That's okay. Okay, so there's our first equation right there. Okay, and then the second one, I'm just going to write, well, we'll do it this way. So the second puppy weighs 4 pounds at birth, but then they grow a little bit faster at ½ a pound per month. Okay, and some people just like to see it in y equals mx plus b a little bit. It's a little bit easier for them. I'm one of those people. All right, now we're ready to graph. Now notice our axes are off to on the bottom and on the left. Okay, and so for the first one, we're at 5, so we're going to go up 5, 1, 2, 3, 4, 5. And our slope is 0.25, which is 1/4, right? So we're going to go up 1 and over 4. So up 1 over 4. 1, 2, 3, 4. Up 1, 1, 2, 3, 4. Up 1, 1, 2, 3, 4. We'll go all the way across. 1, 2, 3, 4. All right, so there's our puppy 1. Okay. And now for puppy 2. We'll do puppy 2 in green. This time they start at 4, but they go up 1 over 2, because right, 0.5 is 1/2. Okay, so then again up 1 over 2. Oh, we found our intersection point already. Up 1 over 2, up 1 over 2. Just do a couple more for good measure. Up 1 over 2. That's probably good. We're just looking for that intersection point. Okay. Now remember, this was weight if we were to label our axes, and this down here was how many months? Because our problem said per month, right? So they weigh 4 pounds and 5 pounds, and then after month 1, they weigh this much. After month 2, they weigh this much. After month 3, they weigh this much. After month 4, etc. 1, 2, 3, 4. Okay. And 1, 2, 3, 4, 5, 6. All right. Now we have to find the intersection point. We found it right here. right? And so our final answer is 4, 6. Now, what does this mean? After 4 months, the puppies will both weigh 6 pounds. All right, last one here. Oh, sorry, 2 more. I'll try to be quick about this. Now, we need to get this into y equals mx plus b. All right, and so up on the top one, the only thing I need to do in order to get y by itself is to divide by 3. So I'm going to divide every single piece by 3. Okay, so we end up with y equals, now this is technically 1/3 x minus 2/3. Okay, so we go, we plot our point at negative 2/3, so like right here maybe, and then we're going to go up 1, which is going to be at 1/3, and then over 3 right here. Okay, and then up 1 again, and then over 3. It's a little tricky because they're on the thirds, but we'll do our best. Up 1 over 3. We'll call that good for now. Now this one, we need to divide by negative 6 to get y by itself. So we get y equals negative. Now, if we have negative 2 divided by negative 6, that's just 1/3, right? Plus, and then, minus 2/3. Oh, interesting. These are the same exact equation, aren't they? And so my points are going to be the same exact points. And my line will be the same exact line for both of them, right? And so how many solutions do I have? How many times do they intersect? Well, they intersect infinitely many times. So infinitely many solutions. Anytime your lines are the same exact lines, it's infinitely many solutions. All right, our last one here. We're going to graph these real quick here. So negative 6, 1, 2, 3, 4, 5, 6. And we're going to go up 5 over 1. And I'm going to pause this and graph it quick and come back. All right, I graphed my lines. Now notice they have the same exact slope, don't they? Both of these lines have the same slope. And what does that mean in my graph? Well, it means the lines are parallel. What happens if the lines are parallel? Well, they're never going to intersect. And so I don't have a solution. No solution. All right, so if they're the same exact line, you have infinitely many. If they're parallel, you have no solution. If they intersect, you have one solution. That's section 1.